Let us solve this problem. Simplify log 27 base 9. 27 is the number and 9 is the base. And so we think, is there any way we can express 27 and 9 in a uniform base? Alright, so we think log 27 can be written as 3 raised to power 3 and 9 can be written as 3 raised to power 2. And so, having written this, we'll think about the laws of logarithm. In my previous videos, I talked about the laws of logarithm, so you can check that out. And so, you need to know the specific law that will be useful for every problem. And so, in this case, we think about this law that says log a raised to the power of n base b can be expressed as n log a base b. N represents the power of the number, and so it is now expressed as the power goes to the back times the logarithm of a base b. So when you look at this, we started with log 27. 27 was expressed as 3 raised to the power 3, and so the power here is 3. Applying this law here, this goes to the back, it becomes 3 log 3 base 3 raised to the power 2. We continue to think. We also have a law that makes provision for when the base has a power, and that law is log a base b raised to the power of n is equal to 1 over n log a base b. That is, whenever the base has a power, it can be written as the power goes to the back, but this time around it becomes the inverse of the power. The power here is n, and n is n over 1. So when you flip it, you turn it upside down, it becomes 1 over n log a base b. So applying that here, it becomes, these 2 goes to the back, and then when it goes to the back, it becomes 1 over 2. So this is now 3 times 1 over 2 log 3 base 3. And so, the essence of this is to simplify this expression. And so, there is a law that says that log a base a is 1. All of these are in my previous videos, so please check that out. So we have 3 times 1 over 2 log 3 base 3. Log 3 base 3 is 1. And so what we have left is 3 times 1 over 2 times 1. And this will give us 3 over 2, which is the same as 1 number 1 over 2. I hope that is clear. Alright, so let's go on to the next problem. Simplify log 12 base 5 plus log 10 base 5. Now, what we are talking about is the applications of the laws of logarithm. And so we are applying those laws here. So, log 12 base 5 plus log 10 base 5. Now, this is addition of logarithmic expression in the same base. The base is 5, the base is 5. And so, one of the laws of logarithms makes provision for when we are adding up logarithmic expression in the same base. The condition is it has to be in the same base. And the law is log p, let's say base a plus log q base a is equals to log p times q base a. And so this specifically is for addition of logarithm of numbers in the same base. Alright, so applying that law here, it becomes log 12 times 10 in base 5. And so simplify this, log 12 times 10, that is 120 base 5. And so we are through with this. It says simplify. Now, the condition to this law, for you to be able to apply this law, we must ensure that the coefficient of the logarithm is 1. Ensure that the coefficient is 1. When you compare this law and this problem we have, you see that the coefficient of the logarithm is 1, the coefficient is 1, the coefficient is 1. If the coefficient is not 1, then we need to ensure that the coefficient is 1. And so, in addition to what I've just told you, ensure that the coefficient of the logarithm is 1. I'm going to take an expression where the coefficient is not 1. So you see what you should do when the coefficient is not 1. So let's go on to the next problem. The next problem, simplify 2 log 9 base 7 minus log 81 base 7. Now please, if you have not subscribed to my channel, kindly click on the subscribe button below. In this problem, what we have here is subtractions of logarithm of numbers in the same base. The base is 7, the base is 7. One of the laws of logarithm makes provision for when we are subtracting logarithm of numbers in the same base, and that is log p base a minus log q base a is equals to log p divided by q base a. This means when you are subtracting logarithm of numbers in the same base, provided the coefficient is 1, the coefficient is 1, then you go on to this. So let's get back to the problem. What we have here is 2 log 9 base 7 minus log 81 base 7. When you look at this closely, you see that the coefficient of the logarithm we have here is 1. The coefficient of what we have here is 2. And so we can't at all go on to this problem now. We can't solve further. We can't solve this further right now. So this is good. We can't solve this further. We need to ensure that the coefficient of this expression here is 1. So how do we make the coefficient 1? How do we make this 1? There is a law that says that n log a base b is equals to log a raised to power of n base b. We've applied the law already. And so, when you look at this law, log a raised to power of n base b is expressed as n log a base b. And so, we can go forward, n log a base b can also be expressed as log a raised to power of n base b. Now, you need to look at this law. These laws are very, very important because the laws would be the one to guide you. The law serves as guidance to know what to do. And so, when you compare this expression and what we have here, this would be log 9 raised to power of 2 base 7 minus log 81 base 7. And so, this is log 9 raised to power 2, that is 9 times 9, which is 81 base 7 minus log 81 base 7. As this is this expression, we could apply this law written here at this point, or we can decide not to apply it, because log 81 base 7 minus log 81 base 7 is 1. This is as good as you saying x minus x. Log 81 base 7 minus log 81 base 7, that's 0. And so this is as good as you saying x minus x. Because all that you have here is the same as all that you have here. And so when you subtract, you get 0. So if you also apply the law, you're also going to get the same thing. And so let's apply the law. It becomes log 81 divided by 81 base 7. And so this gives us log 81 divided by 81, that is 1 base 7. And log 1 to whatsoever base is 0. That is, log 1 to whatsoever base. Log 1 base 10 is 0. Log 1 base x 0. The logarithm of 1 to whatsoever base is 0. And so this this problem gives us a final answer of 0. Still simplifying, log 20 over 9 plus 2 log 6 over 5 minus log 4 over 125. Now, you need to understand that when the base is not given, by default, the base of the logarithmic expression is in base 10. For instance, you have an expression like log 5. The base is not given. By default, we assume that this expression is in base 10. So what I have here is the logarithm of numbers all in base 10. And so, log 20 over 9 plus 2 log 5 over 2. Now, the coefficient of what we have here is 2. And so we can apply the first law that says log P base A plus log Q base A, which is log P times Q base A. We can apply that here until we make this 1. So to make this 1, this goes forward. And so I have this as log 20 over 9 plus log 6 over 5 all raised by 2 minus log 4 over 125. And so we can now think of applying this law. And so this is now log 20 over 9 times 6 raised by 2, that's 36. 5 raised by 2, that is 25, minus log 4 over 125. And so, we can now apply the other law that says log P minus log Q, which is log P over Q. So, this is log, okay, we could simplify this further. This is 5 year 5, 5 year 4, 9 year 1, 9 year 4. And so what I have is 4 times 4, that is 16, over 5, divided by 4 over 125. And so this is log 16 over 5. Changing this to multiplication, you invert the next fraction, 125 over 4. And so we need to simplify this further. 4 year 1, 4 in 16, that is 4. 5 year 1, 5 in 125. 5 in 12, that is 2, that is 25. And so what we have left is log 4 times 25, 100. Remember, we are working in base 10. And so this is base 10. Good. I told you that when the base is not given, what we have is an expression in base 10. And so, because we want to evaluate this expression, we can solve further. We can simplify this further. And so, we have this as log 100 can be expressed as 10 raised power 2. Now, we need to be proactive. You need to think ahead. Think about your next move. The base is a number in 10. And so we think, is there any way we can express the number? The number here is 100. Can we express 100 in terms of base 10? And the answer is yes. And so that is 10 raised by 2. So base 10. So with this now, we can now think, yes, I know what to do here. I know what to do. There is a law that makes provision for this when the number has a power. And so this goes to the back. You have 2 log 10 base 10. And so finally, this is 2 times log 10 base 10 is 1. And we have our answer as 2. And so the value is 2. Thank you for watching this video. Please click on the subscribe button so that you don't miss the next video. See you in the next class. Bye-bye.